Thank you for joining this demonstration of Tolam Earth. In this demonstration, we will be showing the operation of Tolam's automated regression market maker. The purpose of building and deploying an ARM in the Tolam market is to drive market liquidity. It does this through pooling and asset discovery, price differentiation, and market making or auto purchasing of tokens. These are some key takeaways. The ARM takes a data-driven approach by making use of token attributes. Research hypothesizes that users use these attributes to identify non-fungible tokens that they wish to list or purchase, and that this ultimately impacts their perceived value. We derive additional data such as vintage, token age, and project's location. We are validating that these analytically differentiate a token's price. We can differentiate token prices through our ARM-based price recommendation model. This was collaboratively built with Block Science, specifically Dr. Zargam and David Sisson. And finally, as we move into the future, we will continue to build better models. To emphasize these key points, we will demonstrate how the ARM ingests and classifies data, how it recommends prices, and the effects of listing and purchasing.
Hi, we're at Object Computing, and we want to give you a progress report on the work on the automated regression market maker. So today we're going to look at being able to submit these various events for an NFT for when it's minted, when it's listed for sale, and once it's been purchased. And we want to talk about how that gets handled and what happens. We're only looking at the ARM, the automated regression market maker, not the other pieces. You won't see a user interface. You're going to see how the API works. And so you'll see we have these messages we'll submit to the message queue, and they will flow through the system. And you'll see a mock-up of a message coming in from the marketplace services to ask for pricing. So let's go ahead. We're going to actually talk through 3 cases, and I'll refer to those as token A, B, and Z at the end. A and B are quite similar, and Z is different. So let's go ahead. First, we're going to show that 3 NFTs are minted from token A. So we're looking, this is the message that comes across through the message queue for the processing. And you can see the message type is minted. There's the ID. There's 3 serial numbers, 1, 2, 3. They're all in the same project category of renew energy, same project type. They're all from the same owner. Okay, this is one token with 3 NFTs coming in as these 3 NFTs are minted. So let's go ahead and submit this message to the message queue, and we'll see then, this is now looking at the database, and we see that these 3 records have come in. We're looking at, rows 0, 1, and 2. We can see the project category is renew energy. However, we've introduced some metadata that can be used later for the machine learning.
In this ingestion step, raw attributes have come from Hedera and LedgerWorks, such as the token's minting time and its project information. We have derived additional data from these attributes. For example, vintage is derived from the token's date timestamp. All of these attributes are used to create pool assignments, which are the machine learning-based groups of tokens that should be priced similarly. After a seller has minted tokens, they will want to list them on the Tolam market so they can be purchased. To facilitate this, the ARM will provide a price recommendation in the form of a minimum and maximum price, based upon how the tokens have been pooled.
So let's go ahead and submit a request to the pricing service and see what we get. And coming back, we can see these prices. Since they're all similar, they all actually got the same price.
This price recommendation is visible to the seller on the market. With this knowledge, the seller sets their desired list price and makes the tokens available for purchase. The ARM then receives the listing information from the market.
This is the kind of message that comes in. You'll see the message type is listed. and it's got the same token ID, the same serial numbers, and now it just has a listing price.
This is the message ingested by the ARM, and then the resulting data that is saved to the ARM database.
Somebody's going to purchase these NFTs. This is the message that would occur once they have been purchased, and you'll see there's a listing price there and also the purchase price.
Again, this data is ingested by the ARM, additional data is derived, and it is saved.
And we see that it's changed over now. The NFT state down towards the bottom says purchased, and now it does have an average price and it has the last price. What you'll see is that we only purchased 2 of the NFTs, not all 3. So in our database, when we look, we see that 2 of them have a state of being purchased, and 1 of them still has a state of being listed.
In this next part of the demonstration, we mint 3 additional NFTs, but this time from Token B. Token B is very similar to our previously minted NFTs from Token A. However, the owner and state where the offset was produced is different. We would expect that the NFTs from Token B should be in a similar pool to Token A and therefore be priced similarly. Let's kick off the ingestion process.
So we started with the first 3, and now we have a second 3. So let's go ahead and submit a request to the pricing service. And what we see is that because this was in the same category, they were so similar, we actually got the same pricing recommendations coming back. All right, now we're going to go through one more scenario. We'll call this token Z. These are also quite different in that they're different project category, they're in a different project type, they're in a different country, different vintage year. We would expect the pricing should be somewhat different. So let's go ahead and submit this first just to show that they're minted. So we used to have 6, now we have 9 NFTs because we have the 3 new minted ones. And if we look at those, they're sort of, well, it has a different NFT age because it was minted more recently. But you'll see, we haven't priced, hasn't been purchased yet. So there's no average price, no last price, different country. So it's just different from both A and B that we saw. Okay, now, so let's try and price these and see what happens.
Pool Z had a different project category among other attributes, which caused it to be assigned to a different pool, and therefore have a different price recommendation.
Let's have a look back at the high-level diagram that we started with. And what we showed you is we saw 3 different NFT lifecycle events coming in through that great integration service, putting them onto the message queue, the Google Pub Sub, and then the ingestion service handles. We saw 3 different types of events: minted and listed and purchased. And we noticed that there's this both classification happening, getting assigned into pools, as well as transformation, creating these new features, the metadata, things like the average price, the last price, which is information that we want to feed in later to the pricing mechanism. And then the pricing requests come in a different way, but come in directly from our marketplace service. We, again, emulated that today, but those requests came in and we used the data that we already knew about the NFTs to suggesting a price range for where the user might want to price their NFTs.
As we start to expand the capabilities for the ARM, we see 3 more phases of development. Phase 1. Integration of real data to validate the assumptions made in the ARM. Phase 2. Dynamic model training and assessment with real-time ingestion of data from the Tolam Market. Phase 3. To launch a robotic arm when sufficient data threshold is met, collaborating with Block Science to hammer out the details of this launch strategy. That concludes our demonstration of the Tolam Market and the ARM.